There has been an increased demand for blueberries as they have become recognized as a superfood. This has led to the development of automated and semi-automated harvesters. The drawbacks to these harvesters are that roughly half of the blueberries are lost, and what blueberries are collected are bruised and are unable to be sold on the fresh market. This method is okay for large blueberry farms, as they are still able to generate a profit off this method, but for small and medium-sized blueberry farms, the only way to generate a profit is to sell blueberries as fresh market blueberries. This means they need to collect blueberries via hand harvesting to limit the amount of bruising. Due to recent border closures, farmers have been unable to employ experienced migrant workers. As a result, inexperienced New Zealand pickers have been used to harvest blueberries. Regrettably, New Zealand pickers have been found to be less effective as their experienced migrant pickers, and are not attracted to the job of blueberry picking. As a result, small and medium-sized blueberry farmers are losing money and need a method to collect blueberries at the same quality as hand harvesting, but requires less effort for their pickers to make it a more attractive job. Our solution therefore needed to be ergonomic for its users, while ensuring that the harvested blueberries were not bruised. From a conversation with a local blueberry farmer, the utilization of suction to remove a blueberry from its bush was suggested. As this came from an experienced farmer in the industry, it was used as the core of our design, and to keep the design simple, the suction to the system would be provided by a household vacuum cleaner, making the harvester essentially an attachment. The nozzle of the vacuum cleaner would be inserted into the vacuum harvester attachment, with a filter separating it from the collected blueberries. The leading cause of blueberry bruising is the dropping of the blueberry onto a hard catching surface. To prevent this, we utilized centripetal force to roll the blueberry down into a bucket rather than being dropped. To slow the descent of the blueberries into the bucket, a slight angle would be placed on the surface of the attachment. This angle also provides a wedge which seals the bucket and the vacuum harvester attachment together, allowing greater suction force to be applied to the blueberries to be harvested. Due to the current lockdown status, the final blueberry vacuum harvester attachment could not be completed. However, the prototype was tested to determine the design's effectiveness. The suction force produced by the vacuum harvester attachment was tested using a force gauge and a fake blueberry. Through the use of nozzles, it was found that the vacuum harvester attachment was able to produce more than the necessary force to remove a ripe blueberry from its bush. Also, from the use of a visual bruising assessment, it was found the vacuum harvester attachment caused no bruising to the blueberries it harvested. Now that the effectiveness of the blueberry vacuum harvester attachment has been determined, the next step will be to gather field test results to determine how ergonomic the vacuum harvester attachment is compared to normal hand harvesting. To demonstrate the effectiveness of the vacuum harvester attachment, a short clip showing it vacuuming up marbles will be shown soon.